Okay, I got the knuckle case apart. So these have been honed and lined up right now. So now the bearings are straight with each other. Now I individually hone them to the size I want and finish getting the hole rounded out, because right now the holes have taper in them. Right now they seem to be pretty round, but they're tapered. So mostly that's because of the stones I'm using over here. With this machine, the old machine, I can't stroke them all the way across the stones like I need to. I bottom out in the back over here, so I can't hone what I want to do. When I was in this machine, you can see how the spindle sticks out a lot further than anything else. I got room to go all the way back and stroke. But that one's down, so I'm using the old one. Alright, so I did the job I need to do. I got them aligned with each other. Now it's just a matter of figuring out what bearings we need and making it all work. So this here is the crank sitting over here. I had to go figure out what I did with it. Oh, it's right in front of me. It's the worst place to hide stuff, right dead smack in the middle of where you're working. Alright, so transfer it to the workside bench over here. Machine parts that matter. And got all the small stuff over here. There's the old case race we don't need anymore. But we do need all the cages and stuff, so figure out what I did with all that stuff. Put them someplace. So here's the old rollers. Oh, there they are. I thought this was the case hardware. No, it's the bearings. Okay, we need all this we don't need. I'm working on that right now. Okay, that's the junk box for now. Okay, so now let's go over here and work on here a little bit. So we got to figure out what bearings we need. We already know we're going to be oversized. It's just a matter of how much oversized. Okay, that stuff. Don't lose these two set screws fit on the crank. Put this stuff where you won't lose it. It'll be right over here. Because I don't go over here looking for anything. So they should be safe there. Don't forget to put them in the crank. I could put them in the crank right now, but I like waiting until I'm ready. Make sure I'm done with doing everything I need to do. Okay, so we got our washers. We got 3 washers, we're missing one. We only got 1 snap ring, we're missing one of those. Our nuts over here. We got our 4 cages. So we're missing the other parts, I guess. So recall I searched through all this stuff before. So I didn't get all the parts when I got the motor, I guess. So I did not get a complete motor, so we got what we got. Alright, so the thrust washer, no big deal, because I have to set the end plate in the case anyway. But I am missing one of these washers, and it looks like we got the 2 thick ones, and we're missing the thin one. There should be another thin one like this, without the titty on it though. That's the one that's missing. So I'll double check the other motor, make sure it's not with his stuff, because his motor did come in complete. So we'll see. Alright, so we have no bearings for this one yet, so we have to figure that out all out. So the first thing I do is measure up what we have. I guess the first thing I do is set my 4 gauge to standard. Every time you go to use it, you got to reset it because the temperature changes. It will change up to 3/10 just by air temperature, but 1 to 2 is common. So right now I cleaned the dial, so I know I spun it around a lot. So I know it's not even going to be close right now. Okay, so you go back and forth a few times and find the sweet spot. See, right now I'm going over 0, so I got to crank it up a little bit more. Spin this around here. Don't check in one spot, obviously. Looks like we're pretty close. Okay. We're easily within 1/4 of a tenth, which is pretty damn close. That'd be 1/10 of a thousandth and 1/4 of that. So that's 25 millionths, 6 digits over. Sounds impressive, but it's 1/4 of a tenth, big deal. Okay, so now this is set. Now we go over to our case over here and measure our case. Let's do the left one first, you know, it's right in front. Looks like we're about 8/10 over 0 right now. That's where we're at right now with a rough hole. So now we got to figure out what bearings we need to get us up to at least a thou bigger in stock. Theoretically that'd be 4 to 6/10 over, but we don't know what size our shafts are. So we have to measure our shaft and measure our rollers and calculate. So we get out the good mic. The good mic has carbide tips on it. The crappy mic has heat treated tips on it. And it's just as accurate because I set them. Carbide stays stabilized a lot longer, but it's not like it changes very often. I change them like every, 6 to 8 years. It's not like I really wear them out any. As long as you don't drop them, you should be fine. Okay, this should be a 1-inch shaft, I'm thinking. Hey, it is a 1-inch shaft. So let's go ahead and figure out what size it is. Bonus, we're oversized. That helps us. We're about 1/4 of a thou over. So you can see the 0 right there. We're above the 0. Now you go over to the veneer scale over here and you find where the line lines up, and it tells you how many tenths you're over. So right now that one has it at 1/10 over. First line lines up with that, if you can see it. But I got to check it on the part. When you pull it off, it changes a little bit. So we're going to actually put it on the part and check it on the part. Okay, on the part, still 1/10 to 0, between 0 and 1/10. Call it 1/10. Okay, now we spin it because we know it was out of round. It was out of round when we were trimming it. This one measuring it, doesn't measure out of round. And I also can't measure where the indicator was at. That's true in it. Okay, so basically about 1/10 over. So on bearings, I usually use 9/10 clearance, but being a motor has poor lubrication and tends to be not very accurate, they flex around a lot, you use a little extra clearance. So that means we're going to go at least a 1 thou clearance, if not 11. You can go up to 12/10 too if you want. That's 1.2 thou over. So if we just round it to 1 and then cheat another one after that, we'll be fine. So 1 thou and then 1/10. Those 1 and 1's not 2, it's 11. 11/10 to 12/10. There you go. Okay, so we're basically at 0. Okay, so now we gotta find some rollers to fit in there. So I bought all my rollers. They're over here. There's some extra parts. I'm gonna want to put a seal in the case, so there's a snap ring and a seal. Here's washers. There's the washer we need. It's missing this particular one, if we need it. So these two parts here we should need. We're going to use to put it together with, most likely. need. Here's this cam cover. We don't need that right now. Okay, these are the early bearings over here. You got gooey touching the box. How did that happen? I must have touched something else that was gooey. Thought I cleaned everything. I found something with oil on it. I don't think I touched the case over there. Maybe I touched the case over there. That'll do it. No, I did touch that dial indicator over there. Maybe some oil on that still. Could be. I found some oil on something. Alright, put this stuff over here so I can see them better. Okay, so right now I got to figure out what I got going on here because I don't know. Okay, the left main bearings are the same as the right bearing on a newer bike. Standard. Where's the number at? Can you read that? That's the right roller, I recognize it. 9220, there you go. Standard. Okay, that is the roller for the left side. That's what we're doing. So that takes these long ass cages. The other roller takes these two cages together. It's a longer roller. So it's going to be one of these two over here. I'm not sure which one that is yet, but one of them. This is XL tranny. And then we go into weird stuff after that. Right crankcase, sports. This box, no. This box here, probably yes. And these are big twin tranny rollers. And then we move into other stuff. 4/10 over for what? Tranny. 1/8 diameter roller is a tranny roller. That's 4-speed stuff. Over here we have 4-speed stuff. Okay, now we move into big twin stuff. There's some big twin rollers. So when you put these two together, like that, the roller fills the hole. So that is 9261 is standard. We're going to wind up using some of these bigger ones over here. And this is a bag that goes over there, that goes into that box. Okay, so this is the right side, which is that one. Sportster, which we're not using. And this is the big twin roller that we are going to use. I'm going to go right to big stuff. So these should be 8/10, which is what I want to use. 8/10 should be 6/10, because they always cheat on the diameter roller for some reason. And I have zeroed my mics out and checked them 100 times, and it still comes out the same way. Standard bearings are undersized. Most of the time, but not always. Depends on when they were made. If they're made 20 years ago or older, they're probably correct size. If they're made within the last 20 years, they're probably undersized. Okay, there's our roller. I'm going to measure it and see what it is. See how we're over 0. Spin all the way around until it lines up with the veneer. And it looks like we're on 5. So an 8 over roller is only 5/10 over. So that's 1 thou oversized. Oh, we don't need that because I forgot the shaft's not there. See, most times the shafts are undersized. I forgot about that. I'm thinking like an old motor, not like how this one's made. Okay, so this, the shaft is 1/10 over standard, or 1 inch. We're going to run at least 1 thou clearance. That puts us at 11 to 12/10 with the standard bearing. The case over there at 8/10 is on the big side, so we got to hone out 3/10 minimum, so we can use a standard bearing theoretically. Did I confuse anybody? But remember, standard bearings are not standard. So that's going to take away some of our number. That's why you always go real world numbers, not fake number. See how standard is way under 0? That's not good. So we're actually 7/10. That's 3/10 under. That's dropped 6/10 off our number. 6/10 off our number puts us nothing to hone. So we're not using standard. Some people might be a little slow in not catching up. Okay. Now we go to 2/10 bearings over. They should be close to standard, which is going to give me what I want. So you measure that one, and see we're already on the 0 right there. That's a good sign. And it looks like we're between 0 and 1/10 over. Oops. Didn't need that, did you? So I sprayed a little bit of oil so they don't rust. So I'm going to go ahead and wipe it off on a clean rag. It'll be my shirt. I'll remeasure it. You rotate the roll a little bit with your tension on it. Make sure there's no grit. And then you lead it again. It looks like it's pretty much right on 0, just a tick more, but it's not up to 1/10. So we're going to call that 0 for now. I'll probably add an extra 1/10 in overall because that'll give me the extra half a tenth. Undersize I'm reading. So now we got 1. We have standards. We add 1/10. So right now we have a 1. Okay, we add in the bearing, which is their standard size. So we have to add our clearance of 1 thou. So now 1 thou makes, you add 1/10 plus 10 makes 11. If we figure an extra 10th on the bearing because it's a little goofy, that makes it 12. 12 would be 1.2 thou over standard. So that means we're on this gauge right here. 1 is 10. 12 would be 2 over. So between 11 and 2 is where we want this thing to hone out at. Somewhere in that area. It's better to be a little bit loose than tight. Tight is really bad. So I don't have a problem being at 12. So we're going to be right there between 11 and 12 on the gauge, and that's on the average of what the hole is. The hole, hopefully we'll have it within 1/2 a tenth. I like everything under a tenth, about a roundness taper and all that stuff. But we'll see what we got to work with. We don't know. All right, so that's what we're going to go figure out. So I'm going to figure that out. I'm going to go do some honing. We'll be back.